This video is an introductory video to the impulse turbine experiment. This experiment is located in the fishbowl. So the group that is doing this experiment needs to report downstairs and go to the fishbowl to access it. This is a small turbine inside this encasement. Turbine runs on compressed air blowing through these nozzles onto the turbine. The turbine itself, the armature, comes out to this point where a leather strap is placed around the armature and around this lever system, in which you turn a screw here in order to tighten a strap to impose a force on the turbine armature. As you can see, it's connected to a lever above it. The strap is connected to a lever which registers the force. There's a force transducer there, and the force is displayed on this display in units of newtons. This temperature here is going to be the point where you measure the inlet and outlet temperature of the air going in and out of the turbine. In order to look at the two different temperatures, you have one temperature displayed, and then when you hold down this switch actually flicks back, so you need to hold it down to get the second temperature reading. This will give you the flow rate of air. Again, there's a floater here that floats up around where a measure of flow rate would be for the air going through the cylinder. There's instructions about how to take that flow rate. The other display here gives you the RPM speed of the turbine. So when you come down, make sure you turn on the unit as it is now. You got to come back here, make sure that this lever is turned down. That'll turn on the air pressure. Another note is to make sure that you wear earplugs. Earplugs are located against this wall in the fishbowl. Everyone who's doing this experiment is required to wear earplugs. In order to activate the experiment, you just need to turn this knob. You turn it to get until you hit the inlet pressure point that you need. So I'm going to go ahead and set this to 50. Okay, and then I'm going to stop speaking because it becomes really loud. So I'm going to turn this to 50, and you'll see the RPM speed increase. And then what I'll do is I'll turn it off to continue some more dialogue about this experiment. So I'm going to go ahead and turn it on, and you'll see it increase to 50 kilopascals inlet pressure. So you should see that RPM speed climb up to somewhere between 30 and 35,000 RPM. Again, this is the inlet pressure in gauge in kilopascals, so it's 50 kilopascals. Add atmospheric pressure to it to get an absolute. The exit pressure is atmospheric pressure. This gives you the two temperatures, inlet and outlet temperature. Hold it down to see and hold it down in order to see the temperature reading change. So it's inlet and outlet. Aside from that, something else to take note. You're going to go ahead and turn on the pressure to 50 kilopascals. Allow the RPM speed to level out. It might take a minute or two, but you should see the RPM speed stop climbing, and it should level out a little bit. Not exactly, but it should level out. Note the RPM speed. The force should be 0, inlet and outlet temperature. And then what you're going to do is turn this knob until this reads 0.1. All right, should be 0.1 newtons. Now, you might not be able to get exactly 0.1 newtons. It's a little temperamental sometimes, where you might not be able to get the exact number that you're looking for, but try to get close. And then you'll hear it slow down. When it slows down, take the new RPM reading and your inlet and outlet temperatures. The flow rate and the inlet pressure should not change. Once you get 0.1 newtons, increase it to 0.2. Again, wait for it to settle out. Take your new RPM speed and inlet outlet temperature. Note the force. 0.3, 0.4, 0.5, and keep incrementing the pressure in increments of 0.1 and taking your readings until the turbine stops spinning. Once it stops spinning, you take your final temperatures and then basically turn off the pressure, relieve the force on the armature, and then go back and set the inlet pressure to 30 kilopascals, and then start the process over again. That should conclude the introductory video for the impulse turbine experiment.